Okay, well in this video we're going to look at a number of different rules, differentiation rules, and in the last video we proved the power rule. You can see the power rule is right here. We're not going to prove any of these rules, although they follow the same line of reasoning. You just use the definition of a derivative on the particular function. So you would use that limit process using c as your function. C is just a constant. So let's just go ahead and look at a few of these rules with some examples. Okay, the first one is if you have a constant function. Let's make one up here. Let's say that f of x equals 2. Well, we know that if we were to graph that, it's just a horizontal line, okay, through the point 2. Okay, so here's 2, and I'm interested in the derivative of this function. Well, think about what that's actually saying. That's actually saying what is the slope of any tangent line to f. And according to this constant rule, it doesn't matter what x is, it looks like the derivative will always be 0. Now this should make sense because any tangent line to a horizontal line will be a horizontal line, and that horizontal line has a slope of 0. Okay, so the derivative of a constant will always be 0. Okay, the next one we looked at in the previous video is just our power rule, and I'm not going to prove it again, but let's just look at a couple of examples. If I have x squared, maybe my function is x squared. Well, my power rule says if I'm interested in the derivative of this thing, the derivative, I take the power, I move it out front, and I decrease the power by 1. Now you don't really have to write the 1 here, you could just write 2x. But I want you to notice something. I want you to notice that this is a parabola and this is linear. Okay, so you could actually check to see if this works, and you know that the graph of x squared is going to look something like this. Okay, it'll look something like this. So 1 maybe, and maybe this is 2, and it's going to come all the way up here to 4. So this would be 4 right here. This would be 1. This would be 1 and 2. Okay, and this is obviously 0, 0. Okay, so let's see if this derivative actually works. If I wanted to evaluate f prime of 0, okay, what am I asking? Well, what's the slope of the tangent line at 0? Plug it in. Plug 0 into 2x, and you get back 0. So the slope of the tangent line at 0 is 0. And that should make sense because we know that the tangent line there is going to be a horizontal line. Okay, what about 1? Let's just see if it checks out for 1. Here's my point on the curve at 1, and maybe I have this tangent line that comes in here and does something like this. Okay, I know my scale is off a little bit, but first thing I can tell is I definitely have a positive slope. Okay, so what if I wanted to evaluate f prime of 1? F prime of 1, if I plug 1 in for x up here, I get back 2. Okay, so basically this yellow line has a slope of 2. So I just want to make sure that you're still tracking with what a derivative is and what it means when we actually find a derivative. Okay, the next one involves a constant being multiplied by some function, any function for that matter. So let's look at an example. Let's say that let's not use f. Let's use h. H of x equals, well, let's pick out a constant. Let's pick out a c. Call it 7. And now let's think of some random function f in terms of x, and x cubed will work. So x cubed is behaving like this guy, and 7 is really my c. Well, what does my rule say? My rule says that if I want to find h prime, that I can take my constant and multiply it by the derivative of my other function. And the derivative of this is just 3x squared. Okay, now I can simplify, and this will be 21x squared. 21x squared is going to describe the slope of any tangent line at a point x. Okay, and finally, the last example, really there's two rules wrapped up into here. It's our sum and difference rule. If I have a function added to another function, then if I want to find the derivative of that thing, I simply find the derivative of each of those functions. So let's do an easy example here. We'll pick 3x squared plus, how about negative 7x cubed. Here's a basic example. Okay, so if I want to find the derivative of this thing, it amounts to simply finding the derivative of f, or 3x squared in this case. And the derivative of 3x squared, I use my constant rule here, so 3 times the derivative of x squared, which is just 2x. Now I know some of you probably did this in your head and you called it 6x right away, and that's fine. So this is 6x. And this guy is going to be negative 7 times 3x squared. So 3x squared is the derivative of x cubed. Negative 7 times 3 is negative 21. And 6x minus 21x squared, oops, that should be a plus there. Okay, so 6x plus negative 21x squared, or 6 minus 21x squared, is the derivative of h here. Okay, those are some pretty basic examples, but they just help illustrate the different rules. In the next video, we'll look at a little bit more complicated example using these same rules. See you around.